Okay.
Good afternoon, class. Can you hear me from the back?
Yeah.
Okay. Good afternoon. Welcome to Cloud Computing Security. Today, inshallah, we are going to introduce the first chapter of this course. In our previous class, we only introduced the syllabus and the content of it, including the policy evaluation or evaluation policy for the course. So today, inshallah, we are going to introduce the first chapter, which is on cloud computing basics. What are the basics of cloud computing that will give us the foundation and the concept to understand other subjects, or other chapters that will be discussed later. So basically, this chapter introduced the basics of the cloud computing security, and also it will tell us what are the benefits of cloud computing environment or applications. What are the challenges that actually leads to cloud computing to be established? So basically, this is the forward. Because of the many changes that we have now in IT environment, and these changes are coming very fast. That actually implies that users of IT facilities will require more storage, will require more speed, will require more applications, and so many other resources that are there online will be required by us. And that implies also that the normal devices, which are the IT facilities we use currently, will easily be overrun by the number of storage that we actually need. So that implies that we will need to have additional storage, we will need to have additional speed, and also we will need to have space for additional applications. Because of this reason, a business model was designed to cater for this need. So basically, the cloud computing environment is developed to address this problem. So in this chapter, we hope to be able to describe what cloud computing is, basically to give the basic definition of it, and to describe the benefits of cloud, list some cloud services and deployment models for cloud computing, and also to understand the mainstream cloud computing vendors, because we have many companies that provide cloud services, including AWS, Amazon, and all these cloud vendors. So we're going to see some of them, and we will discuss what are the services that they provide to the users. So what is traditional IT environment? Actually, traditional IT environment is like what we have here, normal settings with physical devices. Okay, so in different environments, we have different type of traditional IT environments. Taxis now use applications. In the hotels also they have hotel application. Mobiles uses messaging and call services. In retail environments like the malls, most of them now have applications online that you can actually use to order for stuff in the malls. So that implies also that they will need some software, hardware, and communication related services. And all these services also are changing. After a very short period of time, you will see a new technology will come up, and then you need to have to upgrade basically. So because of this upgrade, it requires us to have some kind of a standard business model that we can always fall back to, that will always help us to address our storage needs, our speed as processing needs, network service needs, and our software needs. And that's one of the things that actually cloud provides. So this is basically the general idea of cloud. Cloud uses what we call data center. So now, for example, if you if you store your files on OneDrive, or if let's say maybe you are using Dropbox, you store your files in Dropbox, where is it going to? If you save the files in Dropbox, we know that Dropbox or OneDrive is our cloud services, right? If you save it, we know that it's no longer inside your device, right? It's saved in the cloud. But then, where is this facility? Because the cloud also must have a facility that will actually host all these files that we saved. So where it's going to is called Cloud Data Center. It goes to the Cloud Data Center. Cloud data centers are very large applications or resources designed by cloud service providers. The companies like Google, they have some of their data center in Portugal. Some, like Facebook, they have in the US and stuff like this. So basically, these data centers are very large facility. Basically, it hosts a lot of information that users actually see. Because of this, you can imagine what happened, for example, on Instagram, or let me say, a typical more example is YouTube. A lot of videos are being saved there, because of how large these videos are saved every day and everything. It means that the cloud data center will be what? Busy. You can imagine if you are streaming a video on your device. After some time, it gets what? Heat, right? It provides some kind of energy. Okay, so it starts emitting heat. And that means that your device needs to have some kind of what? Cooling system, right? So you need some kind of cooling system to maintain your device. So that's how the data center works. All the people that send videos and stream videos from the data center, you can imagine how busy it's going to be because it's worldwide. So mostly data centers are established close to the sea, and there will be a cooling system of water going through it. If you go online, you will see some examples. They are very large facilities. So they also need a lot of space because they are very large. So this is part of what we call infrastructure. So cloud provides three services: the infrastructure as a service, platform as a service, and software as a service. So part of the infrastructure, we can get a lot of storage, we can get servers, network, security, okay, storage, all these are part of what? Infrastructure as a service. Now, I'll give you another example for infrastructure as a service. People that play games knows that now you can actually rent a server. Okay? Those that play games know that you can rent a server online, and you just simply need to configure the server and you can use it to be playing your games. That will help you to increase the speed in which you play the games. Also, people that host websites, because I was lucky to have seen many generations of how the website actually evolves. When I was doing my bachelor's, anytime we design an application, a website, you need to host it on a device. Then we don't have cloud services basically. So what's happening is after you finish designing your website, you make your computer to be what? To be your server. So you host your website on your server. Now the implication of this is simple. Number one, your computer must be online. Must be on 24 hours for people to access the website. That's one. Two, it must be connected to the internet 24 hours. Okay, so you can imagine the maintenance issues that we pass through at the time. Because if your computer goes off, nobody will access your website. If the internet is not connected to your server, because of course now your computer becomes your server, also it implies nobody will access your website. So there's a lot of maintenance issues, power supply issues, internet issues that you have to take care of. Now, the cloud comes in and says, don't worry, we can provide you a server online. So you host your website. Okay, I'm hosting my personal website on godaddy.com, and I subscribe for 10 years. Domain is active, to be active for 10 years. I used to forget I have a website actually. Now, everything that has to do with maintenance, they take care of it. I don't think of maybe my computer will go off, maybe the internet is not connected to my computer. No, I don't need to think about that. It's already hosted somewhere. So anything that has to do with configuration issues, maintenance issues, internet issues, so storage issues, I don't need to think about that. So you can imagine if it's a business. If it's a business, if I have to buy my server and host the website on my server, it means I need to deal with a lot of maintenance issues and also overheads related to costs because I need to buy a physical server. But if I rent the server online, it means that I will be making money while I'm sleeping. I don't need to think about my server will go down and stuff like this. You know? So actually, this is one of the things that cloud provide as a service. So let's go to the platform. The platform as a service simply implies programming platforms. Now, what's programming? Programming also used to be you have to get a compiler on your device for you to run a program, right? If you want to write C++ program, you need to install a compiler, right? After the compiler, then you start writing the code. So also these have some problems related to a lot of issues also because the compiler also will require more space, and if your device is not fast, if you are compiling a program, sometimes it takes long time, especially if you have long lines of code. So cloud comes in to say, okay, don't worry, we'll provide you with programming environments where you can develop your basics, integrate anything that has to do with applications, okay, develop your application, middlewares, everything that has to do with programming. You can do it. A good example is what? For those that are now taking Python, can tell us, you have an online platform where you can write Python codes, right? It's called what? Jupyter, right? That's Jupyter also. Okay. Yes, so there are many of them actually. In this case, it means that you don't need to install the Python compiler on your device. So you just simply need to go online and log in, and then you start writing the code. So basically, this is a good example of what we call platform as a service. Then the last one is software as a service. A lot of softwares, simple example I can give, there are some softwares that if you need to buy and install this type of software, it will cost you a lot of money. Lot of money. So what do you need? How will the clouds provide such service to us? So the cloud say instead of installing the software, buying the software and installing it on your device, no problem. We can give you this software online and you can use it, and we now meter how much time you use it, and then you pay only for the time that you use it. So in this case, you pay a very little amount instead of buying it and installing on your device, which will actually require a huge amount of money. So this type of software, this is what we call software as a service, basically application that has to do with software, collaborative software. Who can give me an example of this? Software as a service. There are many software that we use now. Google Doc. Google Doc is software as a service actually. I can upload Excel file and many people will be working on it at the same time in the log. So it's because actually it's now on a cloud platform.
Is a Blackboard now software as a service or platform?
Yes, there is.
Software, right? The platform we use.
Yes, it's a good example also. So on software as a service, you can have applications related to e-governance, finance applications, telecommunication applications. All these are there, you can use. You only need to pay for the time that you use it, basically. So these are some of the general idea of what is contained in the IT architecture.
Did we know?
Yeah, try to know some example, it would be good. Okay, so I have to stay here. Okay, so IT basics. In a typical IT environment, we deal with a lot of computers. These computers runs on different types of operating systems, Windows, Linux, mobile devices that run on Android, iOS, and also IoT devices, also that run on some different types of IoT operating systems based. So all these actually generate a lot of data that requires more speed, requires more storage, and also more applications to handle. So basically, it causes what we call explosion of content, which actually requires more than what a typical IT environment can handle. So because of that, we always think about what is going to be the solution. Like, so some of the challenges of a typical IT environment, like this lab, this is a typical IT environment. Number one is slow service rollout. If you want to set up this lab, you need to buy all the equipment. After this, you talk about what? Installation, right? You need to get network engineers to come and install all the computers, all the applications, okay, and do a lot of settings before it gets ready. Maybe it takes 1 month to finish. And then we start talking about maintenance. So for you to roll out this service, it takes long time. Okay? Limited scalability. My 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 forensic class, I moved to a new lab and I have only 20 seats. When I check on the blackboard, I realized 24 students enrolled for the class. So now I'm thinking, what am I going to do during the lab session? Where am I going to put the remaining 4 students? Because the class only have what? 20 seats. So it's not easily scalable. If I have more space, I only need to have what? More seats, right? And I can accommodate the 5 students. Of course, I cannot drop them because already they are enrolled into the class. It's now for me to think about how to manage the class. So basically, scalability means if there is need to expand, we should be able to do it easily. If there is need to scale down, also we should be able to do it easily. So in the cloud environment, we deal with virtual machines. Okay, so in this case, if I'm running my labs on the cloud environment, if I have 20 virtual machines to run the lab, and then suddenly I have 24 students, I don't need to worry. Because I can easily scale up, it becomes 24. Okay? So easily I can scale up. Low reliability issue is not reliable in a traditional IT environment like what we have here. A lot of systems get crashed. And if you go back to the example I gave in the first instance, where I used to host my website on a laptop or on a desktop, It's not also reliable because any power outage, which means that will imply that my website may not be accessible. So it's not very reliable. Unlike what used to happen now. Complex lifecycle management. Yeah, the complexity in managing the devices is quite complex as compared to what we have now. The latency issue, especially when it comes to input-output bottlenecks, basically implies it's actually very slow. Okay? In cloud environment, you can scale up also the speed of the machine. Okay? And it means that when you have latency issue, that's when it is slow in a traditional IT environment, it's a little bit difficult basically to scale up the speed. Okay, because it means changing some of the processes. Then the last but not least is high TCOs. What is TCO? Cost of ownership, right? So this is total cost of
ownership.
yes. Let me see. Yep, I'm back. TCO means total cost of ownership. If you want to have a traditional settings like this lab, maybe you spend like $500,000 to set up this lab. That's quite much, right? In a cloud environment, you only need to subscribe for virtual machines, and you will be able to get 36 virtual machines, and you pay less. So to own this, that's to own it, total cost of ownership. To own this makes us to spend a lot of money. So it's not, when it comes to cost benefit analysis in a company, it's not very advisable to spend a lot of money on projects that maybe we may not be able to use it for a long time. A good example is sometimes we have events that are not so frequent. Qatar hosted World Cup, and during the World Cup, you need to have a lot of IC facilities, for which sometimes after the World Cup, maybe you don't need them as much. So if you spend a lot of money on physical IT facilities, by the time the event is over, you have spent so much, and now you are left with physical infrastructure to deal with. So this is also another case where actually cloud can help a lot. Okay, so instead of owning it, there's total cost of ownership. Instead of owning it, instead we go to the cloud and rent it. So you can see, based on the previous diagram, all network infrastructures you can actually rent them on the cloud. Discussion. How can IT enterprise overcome these challenges? What are the challenges that we mentioned? Who can tell me? The challenges of traditional IT environment. It's not scalable, yes. Slow, right?
Expensive.
Total cost of ownership, complexity, or reliability, all these challenges that we mentioned. So how do we solve these problems? Number one is IT infrastructural transformation. We need to change how we deal with IT infrastructure. Second one is resource integration and comprehensive utilization. We don't want to buy things that we are not going to utilize. Okay, so we only buy things that we know that we want to utilize them at a specific time. Once we are done with that, we can move on without any losses from our side. Okay, business collaboration and continuous optimization of the system. So these are some solutions. But then cloud tried to solve these issues. So let's see how it goes. IT development trends. In a traditional settings, now if we say traditional settings means like the present computer that we use. This is how it works. You have a computer, you install your operating system, and then you install your applications on the operating system, right? That's the traditional settings that we have. If you have a computer, you need to install Windows, right? That's the operating system. If you are not using Windows, maybe you install Linux. If it's mobile, then you need to have maybe Android or iOS. Okay, we can say maybe this one it comes with it. But that's the operating system. Then you can start installing applications. So that's the traditional settings. Visualization, which actually is the main technology that cloud is using, try to expand this switch on a single system. If you have a visualization technology, Oracle VirtualBox, VMware, uh, Fusion Compute, all these are visualization technology. Once you have installed on your device, you can create virtual machines. Each virtual machine can have a different operating system, right? And then you can install also different applications on each operating system. And that means that you are utilizing a single machine, okay, creating multiple virtual machines, and then creating multiple operating systems. And then we can use multiple applications on each of the operating systems. So if the machine you are using is 2 terabytes, if you create virtual machines, they shouldn't be more than 2 tera at the end of the day if you combine all the storage that they will use actually. Okay? So basically implies that they are all using the same storage facility. Now, this is the idea that cloud actually borrows. This same idea is transformed into cloud. The only difference is here in the cloud we deal with what? Data center, very large storage space. Okay, so the visualization technology, cloud operating system, then you can create different virtual machines and then different operating systems and then different applications. So this is how the architecture of the cloud looks like. So if you look at it carefully, this and this actually are similar. Okay, so now another important thing that we mentioned is visualization. Visualization is one of the backbones of cloud technology. It's what makes us actually to be able to create servers on the cloud, manage a lot of network resources on the cloud. It's all because of visualization. So this is some of the transformation, okay, from the first platform main framework. Then we have the network type, which is the LAN, with internet and service. And then later on, we start creating cloud. Okay, so cloud, the idea was conceived in 2012, but actually it becomes more popular around 2015. So how do we define cloud now? Before we define cloud, we need to define a computer. A computer is a processing machine, a logical device, and also a processing device, right? With a computer, you can program and create instructions and direct the computer on what to do. This is so basic computing fundamentals, so I skip it. The timeline of how computers actually evolved. This is the timeline. I will skip this one. It's story. More interested. Sorry? History is history, guys. History. No need. I believe you know it already in computing fundamentals. So I skip it. So visualization technology, let's look at it more again. This was before visualization. If you have a server, in the server you have all your network resources, including storage, processing device, processors, and stuff like this. Then you can now install your operating system, let's say Windows or Linux. Then you actually can install your application. Now, look at it carefully. Each of these works on a single computer. Okay, so this is a single computer, you have this. If you have another computer, a different installation. Okay? But in cloud, pooling is possible. Pooling means that we can combine the resources of many computers, use a visualization, sorry? I need to have something to control it. So resource pooling is possible in cloud. With visualization technology, you can have multiple distributed devices, okay, and then use visualization technology to do what is called resource pooling. And all the resources, if this is 2 gig, 2 gig, 2 gig, you can actually have 6 gig, okay, combined here, and then you can create virtual machines and install different operating systems, Linux, Windows, and then you can actually create more applications. Yes. With this also, it gives you what? Shared visualized resources in a pool, okay? So each virtual machine is also using the same storage space created by the pool of operating systems and storage devices from the data centers that you have. Okay, so one of the advantages of this is called shared resource pooling, and decoupled resources are decoupled from physical hardware. So basically, it means that the resources are not tightly together with the physical hardware. I need to still go back to that slide. So, for example, the resources before visualization, the resources here are tightly together with this. Okay? But here, the resources are not actually tightly together with only one computer. Okay? So they are shared pool of resources from the different computers that you have. So let's see now tracks, yes. So this is the timeline for visualization technology. This idea started by IBM, okay? Then they created emulators in 98. VMware workstation started their own in 99. IBM also created what is called APDs in 2004. Zen is another visualization technology started in 2005. KDM, KDS, and now we have even more than this. The containers, the Dockers, these are the new ones that we are using right now. So basically, this is the timeline of how this technology develops. So let's see the definition. We still did not define cloud. So this is the definition of cloud. Important things to remember. If you define cloud, these are the important things to remember. According to National Institute of Standard and Technology, NIST, they define cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. That includes network resources, servers, storage, application, and services. All these can be rapidly provisioned or given or released with minimal management effort or interaction with service providers. So basically the idea is we are going to have service providers. They have these resources, be it the server, a network resources, application, okay, or storage resources. They give it to us as users, okay? That's what is called provision. They provision it to the user with minimal effort. From our side, we don't need to configure a server. We don't even need to know how to configure a server. Okay? They will do that for us. We only need to use it. Okay, so that's what is called minimal management. But before then, I mentioned some very important things: ubiquitous, convenient, on demand. Basically, this implies the resources are distributed. Okay, distributed environment. It's convenient to use, and you only use it on demand when you actually require the resources. That's when you use it. According to Wikipedia, I don't like to use Wikipedia as a basis for defining any IT term. Why? Because it's a very dynamic website, basically. A lot of things can happen, and many people can go there and change. It's edited. However, we saw this definition, which is also very good. They say it's an on-demand availability of computer system resources, especially data storage, computing power, without direct active management by the users. So meaning minimal management by the users is required. So it's a good definition also, and it makes a lot of sense actually. So these are some good examples of definitions for cloud environment. It's basically an on-demand service that help us basically to provide resources, computer resources. You need storage, you go to Google, OneDrive, or you go to any storage facility on the cloud. AWS, Amazon, and all this, they can give you storage space. Okay, and they can also create virtual machines for you to use as servers, okay, applications and services. So if you need it on demand, they provide it to you because they have actually pool of resources. Pool of resources means they have many data centers that are pulled together to give you these resources. And one thing with cloud is it gives you the imagination or the illusion that they have unlimited number of resources. So meaning that if you need 1 million tera, they have it. So you can imagine the number of space they have. They can give you, and only that they will charge you for it. Okay, they will charge you only for the time that you use it. So if you require 1 million tera of space, they will give you. After they give you this, they are not charging you for ownership. No, they are only charging you for the time that you use it. So once you finish using, they charge you a little amount and you pay. That's all.
So it's not useful for permanent storage.
Permanent storage, it is.
Yeah, but we have to pay for the time.
Of course.
So it's cheaper to own our own storage.
It's cheaper. No, it's not cheaper. We just explained it. If you need to have your own storage, you need to have a physical environment to keep the storage.
No, but
You need to.
it's not that big. It's not that big. I don't need, for example, we can use one.
Yeah, if it's not that big, just your computer, yes, you can use it.
That would be more affordable.
Yeah, if it's a small space that you need, it's okay. You can use on your computer.
But institute level, we need it.
Yes, if you need more space. Actually, even with time, even your own space will be small for you.
No, not for me. And
Believe me, because you realize that as time goes on, many of your accessories will also be connected to the internet, and they will also be generating data.
You mean the IoT device?
Yes, your car will be connected to the internet and also be generating data. Okay, and even your movement in the car will be recorded. So where is this recording going to be stored?
The company's going wrong.
Yes. So some of the things that happen with cloud is that let's look at some good example. Cloud albums. Albums include pictures and videos. Cloud music. I remember I watched a documentary. One guy was discussing about when, what is it called? Is it iPad or iPod?
Yeah, the other one.
This the old one that
Yeah,
people used to
iPhone,
use
iPhone.
and connect. Yeah, yeah. When it comes out, he was like, because he is a very big guy in the music industry in the US. He was discussing about when it came out, the technology came out, and the company brought the idea to them, and they all rejected that this is not this is not a good idea. They prefer to produce their CDs and sell them. He said only one company decided to buy into the idea. I think it was Microsoft that started the idea. So the company bought into the idea and they started working with Microsoft. At the end of 1 year, the profit that the company that actually bought into the idea and started, the profit they declared was so amazing that other companies were regretting why they didn't join. And of course, you cannot remain behind. So most of them have to abandon the idea of producing CDs, and they all jump into it. Why? Because you get money as the number of play. How many times people play the music? This is what is being recorded as the hit, and the company basically uses this to pay them. So they realize that they make more money with it. But then that idea is now old because the streaming platforms have taken over.
No, we have
The YouTube, Spotify, uh, I mean Apple Music, right? So you realize that if you have a music playing on these platforms, you get more money than even before. Why? Because it will reach more audience. It's worldwide. It reach more audience, and they also pay them based on the number of people that play music. So this is another opportunity given to us by cloud. Likewise, videos. Before, I remember, you see many people with tapes. Is it VHS or something it's called? The video tapes. And you have to slot it in and it plays. And
VCR, the devices.
yeah. And the tapes will be playing, and if you are not lucky, the tape gets hooked inside, you have to unscrew it and be careful not to make sure that the tape is not caught. A lot of stress. Then the VHS, I mean DVDs came in and tried to take over. But then the DVDs also have Blu-ray DVDs. Okay, so came in, but also they have a timeline. After 5 years, they start to wind out, and you realize that it starts cracking, and eventually the DVDs will not work. Now, Netflix came in. This is cloud also. They came in with a different business model. Don't worry, you don't need to keep anything in your house. All you need is an account. You watch, we charge you per month, and we provide you with more movies than you can imagine.
I still like owning them, although I don't play them anymore.
Yeah, it's good. It's good to own them. So music also, I mean, videos now taking over. Now even on the plane, you can watch movies.
How long will this last until the infant?
We don't know because more technologies are coming in, you know. More technologies are coming in. People can watch movies even with their watches. There are glasses that you can play a movie. And anytime you play one, they record how many times you basically use it. And the company will use this to pay the company that owns the copyright to the movie. The good thing is now they can reach more people and it can be played on more different devices. Before you need to have a TV and basically the DVD or CD drive, I mean, player that will play it basically. But now you don't need all this. You go to many houses, these things are missing now. They're normal.
They don't even have phones. They don't have much.
So now you can play them on different type of devices, you know. So they get more money with this. How about documents? Documents also, cloud is taking over most of the documents. We don't see more physical papers in the offices like before again. Because most companies, they just need to have a subscription with Microsoft 360, Outlook, and then all their communications, their documents saved in the OneDrive and stuff like that. So more documents are stored on the cloud than what we used to have in a physical office, basically. So these are some of the advantages of cloud. Another thing is video conferencing. It's possible to have a meeting now with companies abroad and strike a big deal, you know. Live streaming also is one of the things that cloud storage actually provides. Okay, so these are some good examples also. Any question? Good. We have 26 pages slides, and I hope I'm not too fast. Because these are so basic information. Yes. So when cloud started, we call it cloud 1.0. The visualization technologies used at the time include Zen, KVM. KVM is what? Kernel-based virtual machines. Uh, we have VMware. We have efficient cloud pilots. So these are some of the companies that actually contributed to visualization in 1.0. In 2.0, we have the OpenStack, Microsoft, Hyper-V. And VMware also contributed a lot to make it what is called resource-centric. So basically, the concentration is more of resources. Now we have Cloud 3.0. That's where we have the native cloud that include the Docker and the containers. So also this provides more applications that are designed for the cloud environment. Benefits. Previously, we discussed about the challenges. Now we want to see the benefits. The benefit of having cloud is on-demand self-service. On-demand means only when you need the service, that is when you need to subscribe to it. Widespread network access, you can access cloud services with different types of methods. Resource pooling, like the diagram we showed before, it's possible you can have multiple physical data centers that will be connected together through resource pooling, and these basically resources are provided to the users. quick deployment and auto scaling. You can scale up and you can scale down easily with cloud services. Mid-touch services means that they measure the time that you use. Okay, that's metering. How much time you use. So they will only charge for the time that you use. That's why it's called mid-touch service. Yeah, so this is the comprehensive service models. In a traditional IT environment, user management is at all levels. The user have to buy the physical device, okay, physical storage, the network devices. You are going to be the ones to install visualization, operating system, middleware, runtime, data and application. Everything has to be done by the user. In infrastructure as a service, issues related to storage, server, network visualization will be handled by the cloud service providers. Okay, so here, cloud service providers. While issues related to operating system installation, middleware, runtime data, and applications will be handled by the user. Okay, so you subscribe to a virtual machine on Amazon AWS. They give you the virtual machine, then you have to install operating system. After you install an operating system, be it Windows or Linux, for those that actually work with, if you have done hackathon before, try Hack Me. This is how it works. Basically, they give you a virtual machine. You need to configure a Linux operating system on it. So basically, you can realize that the virtual machine, storage, and everything is being provided by cloud service providers. So you just start with installing the operating system. You want a Linux, you install a Linux. Okay? So all other things up there, you really want to do. How about platform where you write programs? In this case, anything that has to do with network storage, server, visualization, operating system, middleware, and runtime is handled by the platform or cloud service providers. All you need to do is only to write your code, create data and applications. How about software as a service? If you use a software as a service platform like the Blackboard, she gave us a good example, Blackboard, it means actually that you don't need to do the operating system installation, you don't need to install the Blackboard. All you need is simply a browser. You open the browser and you log in, right? So any other thing about how it works is none of your business. It's handled by the cloud service providers. So basically, all things that has to do with configuration, runtime, data, application, operating system utilization, server, storage, and network is all handled by the cloud service providers. Yeah, so we have, when it comes to the model, now, I want to also make sure that we get this right. There are services and there are models. The services are infrastructure, platform, and software as a service. But when you say model, cloud deployment models are the public cloud, the private cloud, then the hybrid cloud. In some literature, we can actually have what is called community cloud. Okay, so public clouds are the ones used by everyone. Okay, Apple Store, OneDrive, all these are public clouds. Private clouds are owned by specific companies. So you can see that here is used by everyone. That's why they have many of it. But this one is owned by only one company. And no one can access it unless if you are a staff of that company. That's why it's private. The hybrid is a combination of features in private and public, basically, which gives a hybrid model. So let's go to the vendors. When we talk about vendors in cloud, Amazon Web Services, mostly they take the lead because they provide storage space, they provide network resources, okay, servers. All these are possible if you go to Amazon Web Services. They will provide these facilities to you, even including data center they have. So only you need to pay when you want to use it. Okay? So they are actually one of the leading companies. Extensive partner ecosystem by AWS, that's Amazon Web Services. They have cloud assessment, migration services, digital marketing, managed service providers, strategic IT consultancy issues, and system integration. All these are services they provide to partners. Okay, that includes also business intelligence, management, CRM, HPC, that's high performance computers, media, storage, and backups. So these are all services you can get with the Amazon services. Let's look at another one, VMware. VMware also provides a lot of visualization technology that are cloud-based. Okay, they provide availability, security, and scalability on their applications. On the infrastructure side, they provide computing, storage, and network also. So these are some of the things they provide. Yeah, so they have digital workspace, cloud environment, application modernization, telco, cloud. All these are services that VM actually provides. That's the company. Huawei, the ones that develop these lights and music. If you want to check their cloud services, you can visit this website. Okay, on-premise, on-cloud is the name of the website. They have different services there, so I think their own section will be more. So they give services related to computer services, network services, enterprise management, distributed business application, storage, security, meetings, hybrid, all types of stuff they have. Containers, media, databases, and IoT services in cloud.
What do containers do?
Containers actually they are actually called cloud native. Cloud native basically means applications that are designed to take full advantage of cloud services. So basically, containers works with infrastructure, it works with platform, and it also works with software because they are designed. These are applications mostly designed for cloud usage, basically to take full advantage of cloud services. So on Huawei also they have cloud management model, okay, which is called cloud stack. There they provide issues related to big data, AI database, Roma, IoT, compute storage, network security, just like what we mentioned in the previous slides. So all these are possible on their cloud platform. Yeah, also they have AI sensors, intelligent NICs, that's network interface cards, faster and smarter SSDs for storage, okay, chip-based root of trust. All these are services, but of course, I don't want to bother you much about this because I will not ask questions related to this section. The section I will ask more questions on is basically where we discuss the technology itself.
Is it not relevant?
The last slide, no need for the last slide. But then let's look at the quiz question. Which of the following statements are true about Challenges faced by traditional IT environments. Number one, service rollout is slow. Number two, expansion is difficult. Number three, it is not reliable enough. D, the TOC is too high.
C, T, and C. It should be more than one. A, B, C.
So actually all of them are true. If we say true, yes, all of them are true, as we've seen in the slides. Question number two. Cloud computing deployment scenarios include public cloud, private cloud, and hybrid cloud. True or false?
True. The cloud computing model.
Yeah, deployment models, yeah, we call our scenarios. So also this question is true. Yeah, so this
About slide number 36 is the examples there involved.
36, let's go through it. Where is 36? This one. This is for AWS. No needs for this one. This is specific to a company.
So we should only know the first line, first sentence.
I would prefer to ask questions related to things that are basically on the technology itself, not on a specific company. For me, yes. But of course, if you want to write the exam, you need to know everything because it's part of the slide. Not the CCQ exam.